In this video, we're going to look at arcs and sectors in circles again, but this time when we're measuring the angle in radians, which arguably makes the formulae a little bit simpler and neater to work with. So we tend to prefer working in radians. But with anything, as with all of this, you need to be consistent about which units you're working in and making sure that you've either decided to work in radians or in degrees and using the appropriate formula. So let's go and have a look. Okay, so recalling that the angle in radians is the ratio of arc length to radius. So that's where we had our circle, and if you had a section like this where that was r and that was r, then that angle in there was 1 radian. Okay, so following on from that, arc length is just r theta. Okay, so that's our first formula. So you can see that's a fair bit simpler than the formula for arc length when we're talking about using degrees. So a couple of very quick examples. Calculate the arc length here. So arc length equals r theta 3 times pi on 3, because this is measured in radians. Those cancel, give you pi. Okay, for this one, r is 8 times theta, 3 pi on 4. That cancels with that, and you've got 6 pi. So with these ones, it's quite okay to leave them in terms of pi. It's certainly neater than rounding. If you need to round to 2 decimal places, you can, but it's okay to leave it as an exact value. Okay, now if we're looking at sector area, so this is the area of our sector when we're talking about degrees. So if we substitute 2 pi for 360, because we know that 2 pi radians is equivalent to 360 degrees, so the area becomes theta over 2 pi instead of 360 times pi r squared. Okay, now the pi's cancel out, which is kind of nice, and you end up with r squared theta over 2, or half r squared theta, depending on how you say it. So again, a little bit simpler and neater to deal with than this formula over here. Okay, so if we use the same circles we had just a moment before, we've got area is r squared, so 3 squared times theta, pi on 3, and then times a half. Okay, so that cancels with that, and you end up with 3 pi on 2 units squared. Alright, and for this one over here, we've got area is 8 squared times 3 pi on 4 times your half. Those two cancel with one of those, and you get 24 pi. Oops, 24. There we go. Units squared. So fairly easy to work out, especially when you've got nice numbers like this that you can sort of cancel out and come out with a nice exact value there. Okay, so segment area, we can do the same thing we did previously. Okay, so remembering that sector area is half r squared theta. Okay, the triangle area is the same. Doesn't matter whether you're in degrees or radians because you're talking about sine, so it's only whether your calculator is in degrees or radians. So it's a half r squared sine theta. Okay, so providing you're using the right motor in your calculator, that'll come out either way. So the segment area is going to be the sector area minus the triangle, so half r squared theta minus a half r squared sine theta. Now you can see these are really quite similar. They've got half r squared in common, so take that out, half r squared, and then we're left with theta minus sine theta. Now this is where it's really, really important that you're in radians, because if you had this in degrees, so say you're talking about 45 as opposed to pi on 4, you have 45 take sine of 45 as opposed to pi on 4 take sine of pi on 4. It doesn't matter what your calculator's in, because this number is just the angle by itself. If you're not in radians, then you could get the wrong answer. So in radians, it's very important for this one. Okay, so make sure that that's in radians there. Okay, so revisiting our triangles, we can come up with the same formula there. So the first one, we've got area is a half times 3 squared times pi on 3 minus sine pi on 3. And at this point, we're going to abandon exact values because you end up with surds and pi and all sorts of things. It just looks a mess. So we'll just go with rounding. That should be 0.815, and that's units squared. and then this one over here is the same sort of thing. So half r squared 3 pi on 4 minus sine 3 pi on 4. And again, using your trusty class pad or calculator, 52.77 units squared. So the principle is exactly the same. We've just made a couple of conversions to allow for the fact that we're using radians instead of degrees. So in theory, when you're measuring in angle, the angle in radians, okay, your arc length is r theta, your sector area is a half r squared theta, and your segment area is r squared, or half r squared, outside theta minus sine theta. So less complicated, easier to remember than using degrees, but just be careful that you are consistent. That's the biggest take-home message from this video.